Hi, in this video, let's talk about in-order, pre-order, and post-order traversal. So here is a quick review of our recursive iter that yields all the data from the tree that we yield from the left subtree first, and then yield the roots data, and then all the data from the right subtree. So we know that when we do it this way, all the data is yielded in the sorted order. So this is called the in-order traversal because the subtree root is visited, or the subtree root's data is yielded in between the left child subtree and the right child subtree. So, the most common example of doing in-order traversal is to visit all the data in a binary search tree in the sorted order, as we just mentioned. Now, if we do not have to visit data in sorted order in a BST, or if we're not doing a traversal in a BST, right, so let's say just in a normal binary tree, then the in-order traversal is not the only traversal that we can do. There are other types or other orders for traversals. Another order that we can follow is what's called the pre-order traversal, and that can be achieved by moving this line that yields the subtree roots data before the yielding of the data of both the left and right subtree. So yeah, it's pre-order because the subtree root is the first one to be visited. So now I'm going to ask you to pause the video and actually try to work out for this tree here which of the number is visited first and which one's next, so on and so forth until the last number. Okay, so hopefully you've done that, and here is the order of the number visited. So just quickly, we always start at the root of the tree, and that is the data that we yielded first. So 23 is the first number, and then we go down on the left subtree before we go down on the right. So when we go down on the left subtree, the root of that left subtree is 8, so that's the next number. And then now we go to the left subtree of 8, the subtree that starts at 8, so we visit 4. And now at this point, the left subtree of the tree that starts at 23, that's done. So now we go down on the right subtree, and the root of that subtree is 42, and there's no left subtree, so we go down on the right subtree, and so we visit 79, 56, and then 91 at last. So hopefully that all makes sense. Now, an example of pre-order, although not necessarily in the context of traversal, is that when we create trees, we obviously create the root first before we can create any of the left or right subtrees, right? So trees, they are created pre-order. Now that we've talked about in-order and pre-order, you would expect that we would talk about post-order next, and that's exactly what we're going to do. And as you probably also expect that to achieve post-order traversal, we just move the line that yields the subtree roots data after the two lines that yield the data from both child subtrees. And now I'm going to ask you to pause the video again and try to work out the order of the number visited post-order. Okay, so hopefully you had a chance to try it. So let's go through this together. So we start again at the root of the tree, 23 here. Now we would go down on the left subtree first, which is here, right? But again, we would go down on the left subtree. So now we get to 4. 4 has neither left nor right subtree. So now we are yielding this subtree's roots data, which is 4. So that's why we yield 4 first. And now this subtree is done, and we're going back up to the subtree that starts at 8 and try to visit its right child, but there's nothing there. So this both subtrees of the subtree that starts at 8 are done, and now we yield 8. So that's why 8 is next. And now the left subtree of the subtree that starts at 23 is done. Then we don't yield any the root 23 yet, right? We have to go visit its right subtree. So you can kind of work out down that we are really yielding everything from the bottom first, right? So the next one that is yielded would be 56. And then when the left is done, left subtree is done, we go to the right. So 91 is next. Both of these child subtrees are done. So now we go back to the root. So 79, and then go back up 42 next. And then now both of these subtrees are done, and we finally can yield the 23 that's at the root. So that's why these numbers are yielded in this order. An example of something that is post-order will be the deallocation of a tree, which is the opposite operation of creating a tree. So let's think about this in just a little more detail. So if we want to remove all the nodes in a tree, and if we start at the top or the root of the tree, so if the root node is the first node that we are going to throw away, then after we throw this away, we don't have access to the left or right subtree anymore. So we're not going to be able to remove those, right? So removal of a tree cannot start from the top, but instead we have to start from the bottom, right? So once we get to the bottom, we can throw away 4, and then now we can throw away 8, but we cannot throw away 23 yet because we still have to get to the right subtree. So we have to start at the bottom of the right subtree. So, 50, 56, and 91, and so on and so forth, until both subtrees are gone, and now we can finally get rid of 23. And if you look at the post-order traversal here, that's basically the order in which, we want to remove each of the nodes during a deallocation or removal of a tree. So that concludes the discussion of in-order, pre-order, and post-order.